Hello. So today's lesson is all about gradients of lines. And for us to be successful today, we need to make sure that we can compare steepness of lines, be able to find the gradients of a line using right angled triangle. We need to be able to find the equation for a gradient given two coordinates and be able to use the equation of a line to draw out a straight line graph. So during this video, at any point, pause it, make notes, and if I'm giving you a task, pause the video, complete it, and then you can check your answers at the end. So I hope you get on okay. So every straight line has a gradient, and that decides which is steeper. So I've got three lines on here. I've got y equals 4x in green, y equals 3x in blue, and y equals a half x. Now, which of these lines is the steepest? You could probably say that the line y equals 4x is the steepest, okay? Because you've got, you can see clearly that if you were to walk up that hill, if that green line was a hill, that would be quite steep and quite tricky to walk up, okay? Now, why is this one steeper than the others? Let's have a little look at the numbers. We've got 4x, 3x, and a half x, okay? So what makes it steeper is that the number in front of the x is larger. 4 is larger than 3, which is larger than a half, which means the bigger the number, the steeper the line is. So the number in front of the x tells us the gradient and how steep the line is. So you want to pause the video and copy that down into your books. So here's a quick task for you. All I'd like you to do is write down the gradient for each of the lines below. Remember, the gradient is the number that's right in front of the x, and then have a little go at these questions at the bottom. So pause the video and it's your turn. Okay, so answers for this are all the boxes. We've got A, we've got the gradient is 8, B, the gradient is 10, C, the gradient is -2, D is 3, E is -4, and F is 0.6. So which of the lines above is the steepest? Well, the steepest one is the one with the highest gradient, so it has to be B. Which line is the least steep? So the least steep is the one that has the smallest gradient. So all those numbers there, the one that's actually the smallest in terms of steepness is F, 0.6. Okay, we'll talk about negative gradients a little bit later on. And says, do you know what happens if a gradient is negative? Well, we're going to find out about that on the next slide. So I've got three lines on here. Let's look more about how gradients work, and it'd be a good idea to copy this down into your book. So the red line has a bigger gradient than the blue line. A bigger gradient means it's a steeper line. So obviously the red line has a bigger gradient than the blue line. And a negative gradient actually switches the direction of the line. So the yellow line actually has a negative gradient because the direction is switched over. So we're going to have a look at these four graphs. Okay, I've got four lines, we've got no numbers on there at all, but we're looking mainly at how steep these lines are. So which of these lines do you reckon has the largest gradient? Remember, gradient is steepness, and the steeper the line, the bigger the gradient. So looking at those pictures, we should be able to see that A has the steepest gradient because it's the steepest line, so it's got the biggest one. Which two lines show negative gradients? So remember what I said earlier, that negative gradients switch the direction. So if you look at lines B and C, they are going in the opposite direction. They're going kind of down. So they are the lines that have negative gradients. If each line was a hill, which would be the easiest to walk up or down? So looking at those lines, which one would you prefer to walk up if it was a hill? I think I would go for line B, because it's the shallowest line. Okay, line B, actually, if you were to walk down that, it's quite gradual, isn't it? Okay, A is very steep, C is quite steep going down, and D is going up, but probably a little bit steeper than B going down. So I would say B is probably the easiest hill to walk down. So let's have a look at how we can find gradients of lines if we're given one. Okay, so on here we've got a graph with a line on, and I want to know what the gradient of that line is. Okay, so what we're going to do is we're going to count the squares. Okay, if you count one across one square and then go up to the line that's given, you will be able to find out what your gradient is. I'm going to show you how that works. So pick a place on the line that has a whole square. So I'm going to go 1 square across. If I now go up to the line, I can see I've got 1 square across, 1 square up. So that gives me a gradient, look, of 1. 1 square across, 1 square up. That's my gradient. Okay, let's do another example. So I'm going to go 1 square across. How many squares do I go up? So I've got 1 across and I've actually got 3 squares up. Can go at any point, this works. So I've got a gradient of 3. 1, 3. 1, 3. Hopefully you can see that. So what I'd like to do is pause the video and have a go at finding the gradients of these lines by counting 1 whole square across and going up to your line and counting how many that is. Okay, so these are your answers for this task. So I've got 1 across, 1 up there. I've got 1 across, 3 up, 1 across, a half up, 1 across, 5 up, 1 across, 2 up, and 1 across and 1 down. So if I look at all the gradients here, all the gradients are going to be how many squares you go up after you've been across. So go 1 across, 1 up for the first one, 1 across, 3 up is the gradient of 3, 1 across, a half up, a half, 1 across, 5 up, 5, 1 across, 2 up, gradient of 2, and the last question, because it's going the opposite direction, we're still going 1 across, 1 down. Because it's going down, we know that it's going to be a negative gradient. So we're now going to move on to how to find gradients of lines that don't have any squares to count, so it's not on an axis. So I've just got a line and I'm going to give us 2 coordinates. Okay, so now we're going to find the gradient of a line between 2 coordinates without counting squares. Okay, so I'm going to show you a method on what to do. Now, this formula here, gradient equals change in y divided by change in x. This is how you find the gradient using coordinates without counting. Okay, so change in y means the difference in your y values. The change in x means your difference in your x values. Okay, so I put on the diagram x and y because each coordinate has an x and y value. We know that already. Okay, so what I'm going to do is work out the difference in the y coordinates and the difference in the x coordinates. Okay, so if I look at my x coordinates, I've got the difference between 4 and 7, which is 3. And then if I look at my y coordinates, I've got the difference between 15 and 6, which is 9. And now I've got my change in y divided by change in x, so that means your height divided by base, 9 divided by 3, which is 3. So this line has a gradient of 3, and I didn't need to count any squares. You could do it like this if you like, write it out like that, 15 take away 6, so that's my y values subtracted at the top, my x values subtracted at the bottom, and then I can work it out like that. It's up to you. Some people prefer to draw a picture out, some people prefer just to do it in their head using the formula. Now I've put the colours here to help you, okay? So if you're starting with the green, remember to start with the green on the bottom of your fraction as well, okay? So kind of just make sure you keep things in the same colour. So let's have a try at another question. If you'd like to pause the video and have a go on your own, go for it. If not, I'm going to do a work through as we go along. So these are my 2 coordinates. So I'm going to do it with a picture first. So I'm going to draw out my triangle and look at the differences between my x values and the y values. Okay. So if I was to make a right angled triangle here, if I look at the difference between my x's, I've got the difference between 2 and 5, which is 3. And the difference in my y's is between 7 and 13. So 13 take away 7 gives me 6. And now I can do my change in y, which is my 6, divided by my change in x, which is 3. And 6 divided by 3 is 2. And that's my gradient of that line. If I wanted to do it in a slightly different way using the formula, I could do 13 take away 7, which is my green, take away red, which is 6. My 5 take away 2, so my green x coordinate take away my red x coordinate, which is 3, and 6 divided by 3 is 2. So again, completely up to you as to how you do that. So Another thing I just wanted to mention, does it matter which one I use first? No, it actually doesn't here. Okay, so normally most people tend to do the bigger coordinate first, but if you did it the other way, it would still work. So let's just have a little look. If I did 7 take away 13 and then 2 take away 5, I just get negative numbers, but then when I do -6 divided by -3, the two negatives make a positive, so I still get a gradient of 2. So it does not matter which way you do the gradient. Just make sure you stick with the same colour of the coordinate first. So have a quick go at these three. And on the next slide, so pause the video, on the next slide will be the answers and a workthrough on how to whether or not you got the right answer. Okay, so these are the three answers. So for A, you should have got 6 divided by 6, which is 1, so a gradient of 1. For B, you should have got 10 divided by 5, which is a gradient of 2. And for C, this one was slightly more tricky because it had a negative in, but I'm just going to show you how you would do it. Okay, so I'm going to do my change in Y's at the top over my change in X at the bottom. So I'm going to do 12, take away 8, because they're my Y values, and I've started with my biggest first. And then I'm doing 1 minus -3. So think about what happens if you've got two negatives together. Two negatives together make a positive. So what you're actually doing here is 1 plus 3, which gives you 4. So you've got 4 divided by 4, which again gives you a gradient of 1. Now hopefully you had a go at that, and if you didn't, and didn't get it right, it doesn't matter. We're going to keep practicing until we get really, really used to this method. Okay? So make sure you're watching out for those coordinates with negatives, because they will be the ones that are more challenging and more tricky, and we're more likely to make mistakes on. So pause the video. This is your next task. Obviously we've got green where there's no negative coordinates, yellow where there's some slightly harder numbers and maybe a few negatives in there, and red where we've got some decimals and like just more tricky gradients. So you might end up with a gradient as a decimal or a fraction, but that is okay. So pause the video, have a go, see how we get on. And these are your answers. So if you want to check if you've got them right, that would be great. Okay, so the next thing we're looking at how to do is how to name a line using gradients and the y-intercept. Now we've talked about each line having a name before, and we were talking about horizontal and vertical lines, but how do we name a diagonal line? Because that has a name too. So every diagonal line is in the format that I've put in this yellow box, y equals mx plus c. Now hopefully you remember earlier that the number in front of an x is actually the gradient, okay? So in this format, whatever that number is, that will be your gradient of the line. And then we've got this bit here, c, which will be a number. This is called your y-intercept. And what that means is where the graph touches or crosses the y-axis, which is your vertical axis. Okay, make sure that's down in your book. And we're just going to have a look at how this links with naming a line. Okay, so here is a picture of just a diagonal line. And if I asked you to say where's the y-intercept, hopefully you can see that the y-intercept is this bit here, this part here where I've put the yellow cross. So that has a y-intercept of 1 because it crosses at 1. So hopefully that's pretty clear. So I've got two lines here, y equals 3x minus 4. Hopefully you should be able to tell me that the gradient is 3 because the number in front of the x is 3. And the y-intercept is actually not 4 but minus 4, which means it crosses down at minus 4 on the y-axis. On B, we've got a gradient of 2 because that's the number in front of the x. And then my y-intercept is 5 because it crosses the y-axis at 5. So what I'd like you to do is pause the video, have a go at this task and see how you get on with it. Okay, I'm just going to go through the answers for this task now. So for question 1, you should have the gradient are all written there, and the y-intercept I haven't actually gone through, but you should be pretty okay with that. Question 2 is write down the y-intercept for each of these lines below. So for question 2a, we should have got 2 for the y-intercept. For the second one, we've got 0. Third one, we've got -1. And fourth one, we've got 1, because that's exactly where it touches all of the y-axes. Okay, the next part is how do we name a line from a picture? So what we're going to do is make sure that we can find the gradient and y-intercept of the line, and when we've got that, we can write it in the format y equals mx plus c. So first thing we're going to do, the easiest thing to find, okay, is obviously with gradient we can count, so we're going to do that first. So we're going to go 1 square across, 2 squares up, which means this has a gradient of 2. And now I'm going to find my y-intercept, so I can see clearly that this crosses at 1. So my y-intercept is 1. So now if I put it into the format y equals mx plus c, I've got y equals 2x plus 1. So 2 was my gradient and 1 was my y-intercept. And that there is the name of that line. On the second one, I could do my gradient first. So I'm going to go 1 square across, 1 square up. So I know I've got a gradient of 1. Let's look at my y-intercept. I can clearly see it crosses at 2. So I've got y-intercept of 2, which means that my equation of the line is y equals 1x plus 2. But I never write 1x in maths because we're lazy. We just write x. You can write 1x, but you don't really need to. Remember, they're always in this format. Y equals mx plus c. So y equals gradient of x plus y-intercept. Let's have a go at these two. Again, you can pause it if you want to have a go, but I'm going to run through how I got the answers now. So this one, my gradient, I've got 1 across, 2 up, got a gradient of 2, and my y-intercept is -4. So my equation, my line would be y equals 2x minus 4. For the next one, my gradient is 1 across, 3 down, but I've noticed that my line is going down, which means it's a negative gradient, -3. And my y-intercept is there, which is 3, so I've got y equals -3x plus 3. We've got 2 more. Again, pause it if you want to have a go on your own. So, gradient first, going 1 across, 3 up. I've got gradient of 3. My y-intercept is down here at -2. So my equation of the line is y equals 3x minus 2. On this one, I'm going 1 across, 1 down. Because I'm going down, it's a gradient that's negative. So it's going to be -1 for my gradient. And my y-intercept is there at 5. So I'm going to have -1x plus 5, but I don't write the 1 in. So y equals -x plus 5. So our next part, and nearly at the end, is about drawing graphs using the gradient and the intercept. So we've got here a question that says draw the graph y equals 2x minus 2. So I'm going to show you a quick way of drawing the graph using what we already know about the gradient and intercept. So I can see from this question that the gradient is 2 and the y-intercept is -2. So first of all, this is where you're going to use the intercept to help you start off the line, okay? Because the intercept is -2, I'm going to start my line there. And from that point there, I'm going to count 1 across and 2 up to find my gradient. So 1 across, 2 up gives me to there, and I'm going to plot another point. Then from that yellow point, I'm going to go 1 across and 2 up and plot another point. And again, 1 across and 2 up. And as you can see, I'm making, if I now join up the points, a nice line, and that there is the line y equals 2x minus 2. Really quick, isn't it? Really, really simple. Okay, let's have a go at another one. So draw the graph y equals 3x minus 3. So I'm going to write down what my gradient and y-intercept is first. So we should by now know that my gradient is 3 and my y-intercept is -3. So I'm going to plot my y-intercept first of all. That gives me my starting point. So -3 is down there. Then I'm going to count 1 across and 3 squares up because my gradient is 3. That gives you my next point. Then from there I'm going to go 1 across and 3 squares up, and 1 across and 3 squares up. Now I've got enough points to join up and make my line, and that there is my line, y equals 3x minus 3. So why don't you now, on a grid of your own, have a go at drawing the graphs and use only the y-intercept and the gradient. Okay, I've got 4 questions there. Draw an axis for each one and plot those lines. Okay, final thing, just our little review to see what we can do from today's maths lesson on gradients and intercepts and lines. So there's 5 questions here that I'd like to have a go at, just to kind of review everything we've done today. And so pause the video and let's see how you got on with that. Okay, so here are the answers. Hopefully you did okay. Okay, so we've got all of the bits in yellow, show the answers for those boxes. So hopefully you found this lesson helpful and it has allowed you to go at your own pace with this, but also that it's quite clear and you can go back and listen to it at any point. So hopefully you've had a good lesson today, year 8. If you finished early, don't worry. As long as you've got all the work done, that's what matters. So thank you for tuning in and hopefully I'll see you soon. Bye.